I can assure you that Pass or Refund is the best resource for preparing for IT exams. We refund your money if you do not pass on your first attempt. Let us now jump into some questions to see how prepared you are. Okay, let's tackle this. You have the following routing design. You discover that compute engine instances in subnet -2 in the Asia Southeast 1 region cannot communicate with compute resources on premises. What should you do? You should pick C. The default dynamic routing mode for a 5PC network is regional, which only propagates dynamic routes to subnets within the same region as the cloud router. Okay, so let's see how you do with this. You're reviewing and tuning secure web proxy at your organization, Mount Kirk Games. Users have reported that they can't reach the documents they need on the Terram Earth website. The secure web proxy rules configuration is as follows. You need to enable access to these documents. What should you do? Going with B, in Google Cloud Secure Web Proxy, rules that target HTTPS traffic need TLS inspection enabled. This allows the proxy to decrypt, if necessary, and then evaluate the target URL path. Here's another challenge. So, you have this private Google Kubernetes engine, GKE, cluster deployment. You've got a virtual machine VM in the same 5PC, specifically in the subnetwork Kubernetes management, with an internal IP of 192.168.4.2/24 and no external IP. Now, you need to talk to the cluster master using kubectl. What's the plan? I'm going with A. So, in a private GKE cluster, the control plane communicates through a private endpoint, 192.168.3.8.2. Okay, so let's move on. You've got this networking setup, right? There are two VLAN attachments, and they're both linked to two separate dedicated interconnect connections. These all end up on the same cloud router. We'll call it my cloud router. Now, those interconnect connections aren't on the same router on your end. They're on two different on-premises routers. You're advertising the exact same prefixes from the BGP sessions for each of those VLAN attachments. But you've noticed that traffic isn't flowing evenly between the two interconnect connections. What should you do to figure out why the traffic isn't balanced? So, the correct selection here is C. To troubleshoot asymmetric traffic flow via dedicated interconnect, you must analyze the dynamic BGP state. So, take a look at this. You've got the shared 5PC setup. 5PC flow logs are configured for subnet -1 in the host 5PC. Now, you also want to keep an eye on flow logs for subnet 2. What should you do? Here's the answer. A. So, in a shared 5PC setup, all network stuff, like 5PC flow log settings for subnets, it's all handled in the host project. Here's the next one. You need to restrict access to your Google Cloud load balanced application so that only specific IP addresses can connect. So what should you do? The answer is C. You see, network load balancing is a pass-through load balancer. So, take a look at this. You made a new 5PC network called Dev, with just one subnet. You also set up a firewall rule for the Dev network to specifically allow only HTTP traffic, and you turned on logging for it. Now, when you try to log into an instance in that subnet using remote desktop protocol, it doesn't work. You check the firewall rules logs in Stackdriver logging, but you don't find any entries for traffic that was blocked. You really want to see those logs for blocked traffic. What should you do? The right pick is D. In GCP, implicit deny rules, the default rules at the end of the chain, don't generate logs. Okay, so consider this scenario. You're designing the network for your organization. You've got 3 dev teams: web, app, and database. All of them need to get to compute engine instances to do their important work. You're on a small network and security team, and you need to give them that access. You want to keep everything network-related, like subnets, routes, and firewalls, under your central control. And you also want to keep things easy, minimizing the work involved. So, how would you design this whole setup? The right pick is a shared 5PC is pretty much the standard Google Cloud way for companies that need one central place to control network stuff, managed by a host project, but still want different teams to be able to put their application resources in their own separate service projects. So, try this question. Your company has 10 separate virtual private cloud 5PC networks with one 5PC for each project in a single region in Google Cloud. Your security team needs every 5PC network to have a private connection to your main on-premises location using a partner interconnect in that same region. To save money and simplify things, this same connection needs to be shared across all projects. You also have to make sure that all traffic between different projects, your on-premises spots, and the internet can be checked using the same third-party tools. What should you do? The right choice is, D. The hub and spoke topology using 5PC network peering allows you to centralize connectivity and security services. What about this one? You've just deployed your infrastructure on Google Cloud. Now, you need to configure the DNS to meet these requirements. Your on-premises resources should resolve your Google Cloud zones. Your Google Cloud resources should resolve your on-premises zones. And you need the ability to resolve .internal zones provisioned by Google Cloud. So, what should you do? So, I'm going with B. To get that bidirectional DNS resolution working between GCP and our on-premises environments, we definitely need to implement cloud DNS policies. Okay, so consider this scenario. Your organization uses a hub-and-spoke architecture with critical compute engine instances all located in your virtual private clouds, VPCs. You're actually responsible for designing cloud DNS in Google Cloud. You need to be able to resolve cloud DNS private zones from your on-premises data center, and also enable on-premises name resolution from your hub-and-spoke 5PC design. So, what should you do? I would go with D. So, to make hybrid DNS work, just use a hub-and-spoke setup. The hub 5PC would have an inbound server policy that lets your on-premises systems resolve cloud DNS, and then there'd be outbound DNS forwarding using a forwarding zone that points to your on-premises DNS servers. All right, here's the next one. You've got a cloud storage bucket in your Google Cloud Project XYZ, right? And that bucket has some pretty sensitive data in it. So, you need to figure out a way to make sure that only instances from VPCs within that same project XYZ can actually get to the data in that cloud storage bucket. So, what should you do? The right choice is B. 5PC Service Controls is the industry standard tool for this specific requirement. Okay, so consider this scenario. You're maintaining a shared 5PC in a host project. Different departments within your company have infrastructure in various service projects attached to this shared 5PC. They use Identity and Access Management, IAM, permissions to manage the cloud resources in those projects. There's also 5PC network peering setup between the shared 5PC and a common services. 5PC that isn't in a service project. Now, several users are having issues with connectivity failures between certain instances in different shared 5PC service projects, and also between some instances and the internet. You need to validate the network configuration to figure out if a misconfiguration is causing all these problems. What should you do? The correct answer is C. So, Network Intelligence Center connectivity tests are really good for fixing complex connection problems in Google Cloud. This includes things like shared 5PC, peering, and firewall rules. They do this by looking at how your network is set up, all without you having to do any manual testing. Let's see how you do with this. So, your organization has compute engine instances across different regions, US East 1, US West 2, and US Central 1. You've also got an existing Cloud Interconnect physical connection on the East Coast of the United States, with just one VLAN attachment and a cloud router in US East 1. The goal here is to design something with high availability. This means that even if a region goes down, you still need to be able to access all your virtual private cloud, 5PC, subnets. And you need to do all of this in the most cost-effective way possible. What would you do? I would go with C. So, Google Cloud 5PC routing is global by default, which means all subnets in a 5PC are reachable from any region. Here's a good one. So, you recently set up Google Cloud Armor security policies to control who can access your app. Now you're noticing that Google Cloud Armor is actually blocking some traffic incorrectly. You need to figure out which web application firewall WAF rule is causing this. What should you do? You should pick B. To troubleshoot Google Cloud Armor, you must view the HTTPS load balancing logs. Hey, try this question. So, you're the organization admin for your company, right? One of your engineers needs to set up a bunch of host projects across different folders and also share subnets with service projects. You've got to enable their identity and access management, IAM, configuration, so they can do all this with the fewest steps possible. What should you do? The right choice is D. To perform tasks related to shared 5PC across an entire organization. The user needs roles that provide organization-wide scope. Hey, take a look at this. So, you recently put some compute engine instances in the US West 1 and US East 1 regions, right? They're in a virtual private cloud, 5PC, with the usual routing setup. Now, your company's security policy says that your virtual machines, VMS, can't have public IP addresses. But you still need those instances to grab updates from the internet without letting anyone from outside get in. What do you think you should do? So, the correct answer is a CloudNAT is a regional component that provides outbound connectivity for instances without external IP addresses. Take a look at this. You're trying to update firewall rules in a shared 5PC, but you've only been assigned network admin permissions. You can't modify the firewall rules. Your organization requires using the least privilege necessary. What level of permissions should you request? You should pick to follow the principle of least privilege, while letting an administrator manage network firewalls in a shared 5PC host project. The security admin roles compute.security admin role is the right choice. So try this question. You're building a new global application with compute engine instances, and it'll be exposed by a global HTTPS load balancer. You need to keep your apps safe from DDoS and application layer. Layer 7. Attacks. What should you do? The best choice is B. Google Cloud Armor works directly with the global HTTPS load balancer. It inspects incoming traffic and protects back-end services from common web attacks, things like DDoS, SQL injection, cross-site scripting, XSS, and other OWASP top 10 threats. Here's a good one. So, your organization's security policy requires that all internet-bound traffic goes back to your on-premises data center through HAVPN tunnels before heading out to the internet. But it also lets virtual machines, VMS, use private Google APIs with private virtual IP addresses 199.3, 6.153.4, 30. You need to set up the routes to make all these traffic flows work. What should you do? The best choice is C. So, to force egress internet traffic through an on-premises data center, you advertise a default route, 0.0.0.00, via BGP from your on-premises router. Here's the next one. So, your company has this resource hierarchy, right? It's got a parent folder, and then subfolders for every department. Each department sets up their own project and 5 PC within their assigned folder, and they have the right permissions to create Google Cloud Firewall rules. Now, the big thing is, these VPCs shouldn't allow any traffic between them. You need to block all traffic from any source, even other VPCs, and only give departments the power to manage firewall rules inside their own VPCs. What do you do? The best choice is D. Hierarchical firewall policies. They let organizations control things at a higher level. Okay, so check this out. You've got 2 Google Cloud projects already in a perimeter, right? To stop data from leaking out. Now, you need to move a 3rd project into that same perimeter. But that move could mess things up for what's already there. So, you need to see what kind of impact this change will have. What's the best move here? Here's the answer. B. 5 VPC Service Controls dry run mode is specifically designed for testing the impact of perimeter policy changes. So, what about this one? You're setting up an HAVPN connection between your virtual private cloud, 5 VPC, and your on-premises network. The VPN gateway is called VPN Gateway 1. You need to make sure that the VPN tunnels created in your project only connect to your on-premises VPN public IP address, 203.0.113.132. What should you do? I would go with B. To enforce organizational security standards regarding VPN tunnel peers, Google Cloud provides the organization policy constraints compute.restrict VPN peerups. So that's what I'd pick. Next up. So, your company just set up a cloud VPN tunnel linking your data center, on-premises, and your Google Cloud Virtual Private Cloud, 5 VPC. Now, you need to get your on-premises servers hooked up to the Cloud Functions API. Here are the things you need to make sure happen. Anvil, some data absolutely has to stay in its original project, and nowhere else. Anvil. Traffic coming from servers in your data center with those RFC 1918 addresses shouldn't hit the internet to get to Google Cloud APIs. Anvil. All DNS lookups. They need to be done right there on premises. Anvil. And finally, the solution should only give access to APIs that work with 5 VPC service controls. What's the plan? So, the right answer here is B. If you want to enforce 5 VPC service controls for your on-premises traffic going over a VPN, then you definitely need to use the restricted.googlepus.com VIP set, which is at 199.36.153.430. Okay, let's tackle this. You need to configure a Google Kubernetes Engine, GKE, cluster. The initial deployment should have 5 nodes, with the potential to scale to 10 nodes. The maximum number of pods per node is 8. Now, the number of services could grow from 100 to up to 1,024. Considering all that, how should you design the IP schema to optimally meet this requirement? Going with D. To size GKE IP ranges correctly, 10 nodes require a /28 range, 16 IPs. Okay, so let's think about this. You're moving a 3-tier app from your own servers to Google Cloud. The very first thing you need to do is set up a new virtual private cloud, 5PC, with an external HTTPS load balancer. This load balancer will send traffic back to your on-premises machines that are running the front-end part of the application. You really need to block bad traffic from getting into your 5PC and wasting resources at the edge. So, you have to set up a policy to filter IP addresses and stop cross-site scripting, XSS, attacks. What's the best way to do that? The right choice is C. To expose on-premises resources through an external HTTPS load balancer, one must use an Internet Network Endpoint Group, NEGI. Now, consider this. You just finished your company's migration to Google Cloud and configured an architecture with 3 virtual private cloud, 5PC networks, 1 for sales, 1 for finance, and 1 for engineering. Every 5PC contains over 100 compute engine instances, and now developers using instances in the sales 5PC and the finance 5PC require private connectivity between each other. You need to allow communication between sales and finance without compromising performance or security. So what should you do? The correct answer is C. A 5PC network peering is the most efficient and performant way to provide private connectivity between 2 5PC networks. Here's another challenge. You've provisioned a partner interconnect connection, right? That's to extend connectivity from your on-premises data center to Google Cloud. Now, you need to set up a cloud router and create a VLAN attachment to connect to stuff inside your 5PC. Also, you'll need to configure an autonomous system number, ASN, to use with that cloud router and then create the VLAN attachment. So, what should you do? The right choice is D. When configuring a cloud router for partner interconnect, Google explicitly requires the use of the public ASN 116550. So, try this question. You want to create a service in GCP using IPv6. What should you do? You should, pick C. To expose services to IPv6 internet traffic in Google Cloud, you must configure a global external application load balancer. What about this one? So, you're setting up a new application, right? It's going to be behind an external load balancer with both IPv4 and IPv6 addresses, and it needs to support TCP pass-through on port 443. You'll have backends in 2 regions, US West 1 and US East 1. You want to deliver the content with the lowest possible latency, all while making sure it's highly available and can auto-scale. Which setup should you go with? The right choice is D. The need for TCP pass-through means we're looking at an external pass-through network load balancer, which is often managed via a global external IP or DNS-based routing across regions. I hope you found the questions helpful. Do comment. How many did you get right? Also, don't forget to check out passorefund.io because we are confident on our content and give you a refund if you don't pass on your first attempt.